So now we're going to look at another example of a break-even quantity. And in this case, we're dealing with a dog kennel. For anyone who doesn't know, that would be a place where, let's say you're traveling and you're going to go stay in a hotel in another city, and maybe that hotel doesn't allow pets. Or for whatever reason, you can't bring a dog with you. So you're going to probably drop it off at a kennel. They'll feed your dog, they'll take it for a walk, make sure it's got a safe place to sleep so that you don't have to worry while you're away, right? That's what they offer. They're basically a hotel for dogs. Okay, so in this case, the dog kennel pays fixed costs of $9,600 per month. Maybe that includes a mortgage payment on a property, paying to have people on site. But whatever the case may be, that's their fixed costs. We don't have to worry about that. That's given in the problem. And we're told that the variable cost is $6 per dog per night. So the idea is that's how you measure how much of their product they sell. Every time a dog stays a night, that's 1 unit of sale, right? So if a dog stays for 3 nights, that's 3 units. If 3 dogs separately all stay for 1 night each, well, that's also 3 units, right? So that every time a dog stays the night at the kennel incurs costs of $6, but then they charge their clients $30. Okay, so that's kind of all the information we've got to figure out if we want to figure out our variable cost and our fixed cost is given, so we could figure out the total cost that way. Right, but what we're asked to do is find the break-even quantity of nightly stays. Okay, well, remember the break-even quantity, that's where your profit function is equal to 0, or equivalently, that's where the cost function and your revenue function equal, right? Where the total cost and the total revenue are the same. Okay, so let's write down what we have here. The cost function, if I write it as C of Q, remember the total cost is given by the fixed cost, which we were told is $9,600, added to the variable cost, which, well, let's say it's because it's $6 per nightly stay of a dog. So let's write plus 6Q. And just to clarify, let's say Q is the number of nightly stays. So if Q is 10, that means you had 10 nights where the kennel hosted a dog. It might be this one dog for 10 nights, or it might be 10 different dogs each for 1 night, but whatever the case, maybe it's 10 nightly stays. So that's what Q represents, the number of nightly stays. Okay, well, they're also going to generate revenue there, right? The revenue that they generate is going to be given by, well, it says $30 per night per dog, right? So we're going to have 30 multiplied by Q. That's going to be your revenue function. Okay, so if we want to find the break-even quantity, that means what value of Q makes these two functions equal, right? So when does the total revenue equal the total cost? That's the equation that you want to solve. So, okay, well, let's set this up. We're going to have 9,600 plus 6Q. That's got to equal 30 times Q, right? So, okay, we'll subtract 6Q from both sides, and that'll give you 9,600 is equal to 24Q. And if you solve that for Q, you'll get Q is equal to 9,600 divided by 24. So that ends up being 400. So that's your break-even quantity. You need 400 nightly stays. That's what it was required to break even in 1 month. So let's write that down. The break-even quantity is 400 nightly stays. Okay, so just to give yourself something to imagine too. Let's say that the amount of roughly they had on average 40 dogs every single night. Well, then that means on the first 10 days of the month, that's how long it would take for them to break even for their costs, and then the rest of the month would all be profit. Okay, so that's the break-even quantity. So what does the next part say? Find the quantity of nightly stays required for the kennel to make a total of $3,000 per month. So now we don't want to break even. We don't want the revenue and the costs to be equal. We want there to actually be profit. Well, remember what the profit function is? The profit, if we write it as a function of Q, it's your total revenue. So it'll be R of Q minus your cost, which was C of Q. Right? And we can actually work out what that is in this case, because we've got a revenue and cost up here. So our revenue is 30Q. The cost is 9600 plus 6Q. So if we clean that up a bit and collect likes terms, you're going to actually have 24Q minus 9600. That's your profit function. Right now we want to know how many nightly stays would the kennel need to host in order to make a total profit of $3,000 in that month. So we want to solve the equation P of Q is equal to 3,000, like that. Okay. So I don't write this down unless you want to write it on scrap paper. But another approach that you could take is you could say we want the revenue. We want the revenue to equal the cost plus $3,000. You could solve this equation or you could solve this equation, and they would both work. They're going to end up being equivalent. If you actually spell this one out, you'll see that it gives you the same thing that we're about to get. So I'm going to delete this just because I want to focus on this equation. So what would that give us? Well, P of Q is 24Q minus 9600, right? And that's got to be equal to 3,000. Okay, we'll solve this for Q. This will be 24Q is equal to what? If I add 9,600 to both sides, I'll get 12,600. Okay, and then, well, if I solve this for Q, now I go Q is going to be equal to 12,600 divided by 24, and I'm going to get 525. So that tells you that, okay, 525 nightly stays. That's how many dog visits that the kennel is going to need to host to generate $3,000 of profit. So let's write that down. So 525 nightly stays are required to generate $3,000 of profit. Okay. So that's another example under your belt now. Okay, so the last example in this section is another one of those abstract examples. It just refers to producing units of a certain product. It doesn't specify what exactly the product is, but we can just speak in terms of general ideas here. Okay, so what are we given? We're given information in this question. I'll underline as I go. So we're told that the total cost of producing 60 units is $300. So that's total cost, mind you. That's not just the variable cost, that's the total cost. So that would include whatever the fixed cost is. And the rest of the sentence actually tells us exactly what the fixed cost is. It's $90. Okay? And we're asked to find the variable cost per unit. And once we've found the variable cost per unit, then we can use that to find the total cost of producing Q units. Well, by the way, whenever you're asked for the total cost of producing Q units, that's just, in other words, find the cost function, right? Tell me what the cost function is exactly, and that's what that amounts to. And then the last part here says assuming a linear relationship. There's nothing mysterious going on there. We'll talk more about linear relationships in the coming sections. I'm going to review some of that stuff. In particular, we'll talk about linear functions and all the properties of lines. But roughly speaking, all that means is this. Look up at this example for a second. Remember when the cost function in our previous example was given by C of Q is 9,600 plus 6 times Q? Look at the form of that function. There was a fixed cost, which was a constant, and then the variable cost was exactly just basically just a fixed constant. In this case, it was 6 multiplied by Q, which was the number of units of the product sold. Well, the fact that it fits that form, that's what we mean by assuming a linear relationship. Another way to look at it is because we're assuming there's a linear relationship, there is actually a variable cost per unit that's a constant, and we can find it, right? In this case, it was 6, right? But in our example, we're not told what that variable cost per unit is. Okay, but based on that assumption, we're going to write out what our cost function might look like. We're just going to have the details missing. So let's write the cost function. It'll be the sum of the fixed cost plus the variable cost. But because we're assuming it's a linear relationship here, we can assume that the variable cost fits this form. I can write it as the variable cost per unit multiplied by Q. The fact that we're assuming a linear relationship means it's safe to write our cost function in that form. Now, of course, this is all in words. Some of these things we have right? Like in the fixed cost here, we're told this is $90. And then let's give this variable cost per unit, let's give this a name so it's not so arduous to write down. So call this M, let's say. Then we can clean this up and write this a bit simpler. So let's write this a bit more simply. So let's write C of Q is 90 plus M times Q. So M is just a nickname for the variable cost per unit. In fact, M is what we're trying to find now. If we can find M, that'll be good. So how do we find M? Well, there's the very first piece of information given in this question we actually haven't used yet. It says the total cost of producing 60 units is $300. What that's actually saying, I'm going to write this as a given in the question. What that's saying is that the total cost of producing 60 units, well, that's C of 60, right? That's the cost function gives you the total cost of producing Q units. So plug in Q equals 60. So we're given in the question that C of 60 is equal to $300. So, and that's how we're going to find M, because watch, C of 60, plug in Q equals 60 over here, you're going to get 90 plus M times 60. Or in other words, I can just write this as 90 plus 60 times M. And that's got to equal 300, and that's how we can find M, because that's an equation of one variable, right? So let's solve this for M. So we get 60M is equal to 210 if I subtract 90 from both sides. And then I can get M is equal to 210 divided by 60, and this actually ends up being 3.5. So in other words, the variable cost per unit is $3.50. So let's first we'll write that down. The variable cost per unit is $3.50. But wait a minute, we got more. There's more that we were asked to do here, right? So this isn't everything. What else were we asked? We're asked to find the total cost of producing Q units. In other words, find the total cost function. Well, we almost had it here, right? The only missing piece of information is we didn't know what M was. But guess what? We just found M. So now just all we need to do is just update the cost function with the new bit of information that we have. So we can update this and say that C of Q is 90 plus 3.50 times Q. And that'll give you the total cost of producing Q units. Okay, so there you have it. That was another example of where we could answer these questions without actually knowing exactly what was being sold here. We can speak in terms of generalities.